Yes, welcome to my YouTube channel Botanical Concept, and in this video we are going to talk about the Mendel's law of inheritance. So before we proceed to the Mendel's law of inheritance, first we have to know something about Mendel's and why the Mendel's is known as the father of genetics, right? So Mendel's was born on the 22nd July 1822, and in the year 1865 he started a experiment about on the plant hybridizations, right? But unfortunately his work were remain unnoticed at that times. And later then in the year 1900 the three scientists, that is the Hugo de Veris, Carl Correns and the Tismar, rediscovered his finding in a postulate and gave a name to this postulate as the Mendel's law of inheritance. And this law opened a new field in a biological sense known as the genetics, right? So what is genetics? Genetics is a branch of biological science which deals with the study about heredity and the variation. So at here the two new terms are arises, that is the heredity and the variation, right? So heredity in the sense it is a process by which the transfer of characters from the parent to the new offspring takes place. So this transfer of characters from the parent to the new offspring or the child, this phenomenon is known as the heredity. And the variation is that during the transfer of characters from the parent to the new offspring, sometimes some changes are seen in the child in the offspring and in the child. So this changes is known as the variation, right? So so the combination of heredity and variation is known as the genetics. So due to and this law was given by Mendel. So this law is known as the Mendel's law of inheritance. So let's see what are the law which was given by Mendel and which is known as the laws of inheritance. So basically Mendel has gave three laws, that is the laws of dominance, laws of segregation and laws of independent assortment. So these are the three laws which we want to talk about today's in this video, and we will discuss subsequently one by one, right? So first, laws of dominance. So let's see what the laws of dominance say. Laws of dominance say when a pair of contrasting characters are taken into consideration for cross, those characters which appear in the F1 generation or expressed in the F1 generation are known as the dominant character, and those characters which not expressed or suppressed in the F1 generation is known as the recessive character. That means in which a cross between a homozygous dominant and homozygous recessive will always express the dominant phenotypes, right? Thus there is always uniform expression in the F1 generation occurs. So the laws of dominance is based on the monohybrid cross experiment. What is monohybrid cross experiment, right? So it is a cross between two pure parents differing in a single pair of contrasting characters are known as the monohybrid pair. And when this pair take part in any type of cross experiment, then this experiment is known as the monohybrid cross experiment, right? So let's see how the monohybrid cross experiment works in the laws of dominance, right? So in the laws of dominance, what Mendel did, he took two plants, right? He took a pure tall pea plant and a pure black pea plant, right, and crossed them. So the gametes of tall plant is capital T, and the gametes of the small plant or the gamete of the dwarf plant or the small plant is small t, and cross to them, right? So after crossing, he surprisingly found that the plant in the F1 generation were tall. Then he started thinking that where the dominance has gone. Then again he allowed natural surfing of this F1 generation, and in the F2 generation, if the recessive characters is occurs, but the F2 generation is not a part of laws of dominance. So he concluded that in the laws of dominance or laws of dominance, only dominant character express its character, not the recessive character, right? Why in the F1 generation plant were tall? Because the tallness is dominant over the tallness is dominant over the dwarf plant or the small plant. Due to these reasons, in the case of F1 generation, plant is tall in nature, right? So we can take examples, right? The curly hair is a good example of straight hair in the human being. Right. So this is the laws of dominance, and the laws of dominance is significant and true, but not universally applicable. You know why? Because there are so many cases where the dominance, where the dominance not express itself fully, or it expressed mediumly. That is known as the incomplete dominance. So that's why this law is also significant and true, but not universally applicable. We can take another examples of it, right? That is when we in the Mirabilis plant or 4 o'clock plant, when we cross when you cross between the white flower and the black flower, white flower and the red flower, it shows pink color flower in the F1 generation, right? So this is the examples of incomplete dominance, right? So that's why although the laws of dominance is significant and true, but not universally applicable. So this is all about the laws of dominance. Now we will proceed the second law of inheritance, that is the laws of segregation, right? So in the laws of segregation, from the reappearance of the recessive characters in the F2 generation, he concluded that means Mendel concluded that the F1 generation factor do not mix with each other, but they remain segregate or separate during the gamete formation. And this is the second law of inheritance, that is the laws of segregation. So now let's see what the laws of segregation say, right? So the laws of segregation say in a allelic pair hybrid, the gametes do not segregate or separate, but during the gamete formation, they receive only one of the two factors from the given trait. So this law is otherwise known as the laws of purity of gametes, because at here what happened, the two alleles are present together, but they do not alter each other. They do not mix with each other. They maintain their purity. So that's why this law is known as the laws of purity of gametes. And likewise that this law can be, that means the laws of segregation can be explained with the help of the monohybrid cross experiment. As we know, what is monohybrid cross experiment? That is, it is a cross between two pure parents differing in a single pair of contrasting character. That pair is known as the monohybrid pair, and when this pair take part in any type of cross experiment, then this experiment is known as the monohybrid cross experiment. So likewise that here also the monohybrid cross experiment works. Now let's see how the monohybrid cross experiment works in the second law, that is the laws of segregation. So in this law, what Mendel did, Mendel took two pure plant having tall and dwarf characters and crossed to them. The gametes of the tall plant is capital T, and the gametes of the dwarf plant is small t. And after crossing, he found a tall plant in the F1 generation, right? Then again he allowed natural selfing of the F1 generation, that is capital T small t into capital T small t, and cross to them. After crossing in the F2 generation, he got four plant that is having tall, dwarf in their phenotypic. You know what is phenotypic and genotypic? Right. Phenotypic in the sense it is the external expression of a gene, right? And the phenotypic means it is the external expression of a trait, and the genotypic means it is the genotypic expression of a trait, right? So the phenotypic ratio is 3:1, because 3 plants are tall here and the 1 plant is dwarf here. And the genotypic ratio is based on the arrangement of their alleles in that particular trait. That is the genotypic ratio. So at here genotypic ratio is 1:2:1. That means genotypic ratio, as we know, genotypic ratio is based on their sequential arrangement of their alleles. So this is the phenotypic ratio and this is the genotypic ratio. So the appearance of the recessive character in the F2 generation proved the law. That means the appearance of the recessive character in the F2 generation proves the law, that is the laws of segregation, right? So so this law is true and significant and universally applicable. And we can take examples. That means all the organisms who is having diploid and whose gamete are haploid are comes under the laws of segregation. That means all the organisms which having the which are diploid and whose gametes are haploids are applicable for laws of segregation, right? So that's why this law is significant and true and universally applicable. So this is all about the second law of inheritance, that is the laws of segregation, right? Now come to the third law, that is the laws of independent assortment. So let's see what laws of independent assortment is. So laws of independent assortment is based on the dihybrid cross experiment, right? So what is dihybrid cross experiment? So dihybrid cross is an experiment where it is a cross between two pure parents differing in a two pair of contrasting character. That means those traits which are present in the dihybrid cross experiment are most contain two type of character. If they contain two type of character, then these traits are known as the dihybrid trait. And when this dihybrid trait are take part in any type of cross experiment, then this experiment is we can say this experiment as a dihybrid cross experiment. So at here, that means the laws of independent assortment based on the dihybrid cross experiment, right? So let's see what the laws of independent assortment say. The laws of independent assortment say that the alleles of the two different genes get assorted into gametes independently of one another, right? So, and in other words, we can say when a dihybrid form of gamete assortment of the alleles, right? Alleles of the different traits is independent of their original combination into the parent. So now let's see how the dihybrid cross experiment work in the laws of independent assortment, right? So what Mendel did here, Mendel choose select variety of pea plant having the yellow round and green linking. Yellow round are denoted by capital Y, and the capital R capital, and the green wrinkle plant are denoted by small y, and the small r, and cross to them. And after crossing, he found that the plant which appear in the F1 generation is yellow wrinkle, because yellow round, because yellow round is dominant over the green wrinkle. So that's why in the F1 generation of this third law, the yellow round plant were appear, right? And then he allowed to natural selfing of the F1 generation. That means he again crossed this yellow round plant with again with this yellow round plant. That means where capital Y small r, capital Y small y, and capital R small r into capital Y small y, capital R small r. After crossing in the F2 generation, he got this variety of plant having the different allelic sequence arrangement, right? Not different. Some few are same, and some are different in their arrange of the allelic sequence, right? So in this case, he got 4 variety of plant having yellow round, yellow wrinkle, green round, green wrinkle, and the ratio is that the phenotypic ratio is 9:3:3:1, and the genotypic ratio is 1:1:2:2:4:2:2:1:1. So this is all about the phenotypic ratio and the genotypic ratio of this particular trait. That means after the F2 generation, he got this variety of plant, and their phenotypic ratio is this, and their genotypic ratio is this, right? So out of the four variety of plant, the 2 were the parental combination and the 2 were the new combination. So the appearance of the new combination in the F2 generation proves the law. That means the appearance of the new combinations which are not parental, that are completely new, right? So this new combination variety of trait prove the law. That means the laws of independent assortment, right? So the law is so the law is universally so the law is commonly the law is true, but the laws of independent assortment is applicable for those which which are on the different chromosomes, not for those which has the same chromosome, right? That means it means that the laws of independent assortment is applicable for those organisms which have the different chromosomes, not for those which have the same chromosome. So that's why although this law is the law is true and significant but not universally applicable. So this is all about the Mendel's law of inheritance, that is the laws of dominance, laws of segregation, laws of independent assortment. So out of these three laws, only laws of segregation is significant and true and universally applicable, but the laws of dominance and the laws of independent assortment is not universally applicable. So this is all about my topics, that is the Mendel's law of inheritance, and I hope this video will be very helpful for you.